Good afternoon, and welcome to this afternoon's Plant Engineering webcast, Managing Assets Using Criticality. I'm your moderator, Bob Vaver, and I'm happy to join you on behalf of Plant Engineering for more information about how to better operate your plants safer and more efficiently. I'm pleased to introduce this afternoon's speaker. Darren Wyckoff is the author of Centered on Excellence, A Practical Leader's Guide to Continuing Improvement, and remains a thought leader in the maintenance and reliability community. He specializes in organizational change leadership and reliability engineering. For the past 13 years, Darren's continued to train, coach, and mentor industrial leaders like Kraft Foods, Wells Dairy, Cargill, Merck Pharmaceuticals, and Alcoa Worldwide Aluminum through the rigorous process of implementing and managing improvement initiatives in support of operational excellence. His ability to translate Lean, Six Sigma, and reliability principles into real-world applications has enabled these organizations to improve safety and environmental performance, increase production capacity, and reduce operating costs. We're always pleased to have Darren talking to our audience on reliability and maintenance issues. And Darren, welcome and good afternoon.
Good afternoon, and thank you. Today's topic is managing assets using criticality. I appreciate the introduction from Bob. I just want to make everybody aware, again, in the event resources on the left-hand side of your screen, there's an asset criticality white paper. There's a bit of a criticality analysis template that you can use to begin applying some of the concepts we talk about today, as well as an asset management maturity matrices that will help you evaluate other aspects of risk-based decision-making and asset management practices. To obtain more information, other on-demand training resources around this topic, I encourage you to visit our learning management portal at lms.eruditionllc.com. So let's begin our topic. One of the founding principles of ISO 55000 is asset management provides assurance that assets will fulfill their required purpose relative to value. Within the project committee assigned to ISO 55000, the intent of this principle was to really make sure that our asset management plans and activities are designed in such a way that gives us confidence that our assets will deliver the expected value of business. Asset criticality analysis is not new because of ISO 55000, but we need to start thinking about how to revamp the practice, this core skill of asset criticality analysis, to make sure that moving forward in our business strategies to be competitive, we're really focusing on that key statement of value. So in today's topics, we're going to talk about what's in the number. We're going to talk about how to maintain the integrity of the number. We'll look at some aspects of how to learn from the criticality number and numbers themselves. And then we're going to have just a short conversation around managing by the numbers. So let's begin with what's in the number. And this is, seems fairly fundamental, but there are a lot of mistakes made here. The first step in setting up an ISO 55000 compliant criticality analysis as a risk model is to define those characteristics that will be used to analyze each asset. These characteristics should cover a very wide range of business categories and align with the enterprise risk management models. Here's the key here. In order to provide assurance of value, the analysis model must define what value is. So I'm going to start by just listing out the first couple of characteristics that most people will base their criticality analysis on. The first one being, kind of a production-centric or customer impact type of characteristic. How do non-conformances of the asset impact your customer? Or how do non-conformances impact regulatory compliance? This is where many criticality analysis models stopped. And when we talk about revamping this practice to make sure it complies with ISO 55000, we need to go beyond this because this doesn't define all the business drivers for your organization. We need to consider the cost of trying to control the risk and usually that's relative to maintenance. That's the easiest way to capture it. We need to look at, we've got to remember that risk is both severity of the impact as well as probability of the impact. So how often does a nonconformance of the asset occur? What's the likelihood that's going to occur again? We also need to look at what's our ability to recover from a nonconformance. Is there a workaround in place? And I was working in an aluminum company not too long ago to where they had 3 different molding operations, and as the aluminum ingots came out of that mold, they passed through about a 20-foot conveyor. And that conveyor went to a holding area where the ingots would then be set up for finishing and going out to the customer. The conveyor itself, rolling conveyors, nobody would ever consider a conveyor to be a critical asset. But if that conveyor did fail, if there was a nonconformance with that conveyor, it pretty much stopped the flow of metal through the factory. There had no way to get metal out the door. So the criticality analysis had to identify the fact that that conveyor had no workaround. It was a single point failure that would stop the process. So we also wanted to look and make sure that recovery means or procedures were a way to validate significance of the asset. Spares lead time, and I know a number of you have questions around how do spare parts come into the equation. We initially want to set up a characteristic when we're analyzing all of our assets of what is that spares time lead time impact on the business value. The asset value itself, if we're unable to mitigate or manage the risk, what is the cost of replacing the asset? And finally, the planned utilization rate. Do we really need this asset? How often do we plan to use it? I've worked in organizations to where there were production lines that operated for maybe 4 or 5 weeks out of the year. So based on that planned utilization rate, how significant is a failure or nonconformance with that asset versus others that are operating 52 weeks out of the year? When we're trying to determine what are the right characteristics to include in the criticality analysis model, we want to think in terms of what drives your current business decisions. We want to think about the business objectives that have been defined for your organization over the next year, next 2 or 3 years. Typically, we see 2 sets of business categories, the financial drivers and the image drivers. And this is just an example from my book centered on excellence. And you can see that the 4 quadrants that we generally see: financial, market, community, and employment. The financial drivers are based on the organization's ability to control the cost of operations. Financial drivers are also used to define the business's ability to sustain the desired capacity, whether that's availability of the asset, throughput efficiency of the asset, or the quality of the product being produced by the asset. With regards to our criticality analysis decisions, financial drivers should help us identify impacts to producing the product faster, producing the product cheaper, or producing a product better than the competition. Image drivers, on the other hand, define the organization's ability to sustain or protect intellectual capital. And they do this through training, organizational structures and roles and responsibilities, and performance management. The business also needs to look at its ability to expand its license to operate within the community. And that can be based on environmental performance, health performance, or safety performance. In our criticality analysis, these business drivers are impacted by failures that threaten the organization's ability to operate cleaner, safer, or smarter. So let's use a kind of a practical example to see how these characteristics come into play. We're going to call these different characteristics categories. And in the example on your screen, we have 3 different business units that are using the same criticality analysis model. The first business unit places a high importance or higher importance on the impact to safety or regulatory compliance relative to safety. The second business unit pretty much weighted all these different categories, these different business drivers equally. And the third business unit put a highest importance or significance on customer and quality impact. So my question is, which business unit is right? Well, the answer is they're all right. Categories should be weighted within your criticality analysis model each time the analysis is performed, and these weightings should be based on the order of significance or importance relative to each business's location, department, or application. Asset management is focused on mitigating risk. Criticality analysis must identify the significance of risk relative to the business in which the assets are physically located. Standardization of analysis models does not mean that everyone evaluates assets the same. Actually, it means that everyone uses the same model to evaluate their own risk. Let's move on to our next topic in maintaining the integrity of the number, and I'm going to show you a quick image. Now that we've got the iPhone 6, it's maybe a little bit of an outdated image, but it's a good illustration of how we maintain the integrity of the number. When Apple moved the iPhone 3 to the iPhone 4, one of the biggest advancements in their technology was the clarity of the text. And this is an example of resolution. That was what really made the iPhone 4 stand out, was resolution of the text. In our criticality analysis models, resolution is going to be the same thing. How clearly can we make decisions? How clearly can we see the data that should be leading us to intelligent decisions? In order to maintain the integrity, we have to have the right resolution. And this is the point where most asset management processes and criticality analysis models go grossly wrong. In many cases, people will use a scale from 0 to 100, let's say, but then they begin grouping within the analysis. They may say that, hey, from 75 to 100, we're going to call that critical. From 15 down to 1 or 0, we're going to call those non-critical. Inevitably, what they end up doing is force ranking all of their assets, and we could be talking about 3,000 or 10,000 assets. They begin grouping them into a finite number of scales, 1 to 4, 1 to 5, A, B, C, D type of thing, and you really lose that resolution. You lose that granularity, and you end up with a fuzzy picture of what's really significant or important to your business. So we don't want to undermine the criticality analysis process by grouping things in that 1 to 5 or A, B, C, D type of scale. We want a grouping, or we want resolution of our scores that provides meaningful data for establishing an asset management program and delineating truly the critical assets to the business, those that have the most significant risk, versus those that are controlled by other means. So let's talk about analysis resolution and get a good understanding of how we come up with the right level of clarity. And then we're going to look at some graphical analysis of where resolution is poor. There's a standard for setting up your criticality analysis model, and that standard is based on a resolution that is equal to the square root of the total number of assets being analyzed. For example, if we were analyzing 10,000 assets across maybe an enterprise, we would be looking for 100 steps of resolution, kind of like the iPhone text, where we're adding more pixels to improve the clarity. So how do we do this? This is made up within each one of those categories. We look at the number of questions being asked in each category to evaluate risk within that business category, and the number of possible answers or selections that a user of the analysis model could select in order to define risk. So if we multiply, in this example, 20 questions by 5 answers in each question, we end up with a resolution of 100 steps. Now let's look at some graphical analysis of how you can determine whether or not you have the right resolution. So here we see a normally distributed pattern, your traditional bell curve. This is a poor resolution of criticality analysis. It does use the full scale range. However, 80% of the assets being analyzed are pretty much grouped together. They're all shoved together there in the middle. So we have no additional clarity after the analysis of what is truly significant to our business. We can look at a right-tailed or a left-tailed, and they tell us pretty much the same thing, that we have poor distribution or poor resolution. In the left-tailed example, we're using the full scale range, but essentially everything is grouped to the right along the x-axis, saying that the scores are getting higher, a number of assets ranking higher in the criticality analysis model. So again, just like we saw with the normally distributed, everything's grouped together. We don't have any further clarity. Bimodal. This is pretty much an indicator of things are falling into two groupings, critical or not critical. And this is a really good indicator of the fact that you may be, relying too heavily on the 1 to 5 or ABCD type of scale. So what we're really looking for, if we were, you're using a histogram, for example, and these are examples of histograms, after you've completed your criticality analysis, you ran a histogram that is identifying how many assets fall into each possible score, from 1 to 1,000 to 10,000, whatever your range is. We really are looking for a random distribution. And that random distribution is going to help us clarify not only what are the top 10 or top 20% most critical assets, the ones that pose risk to the overall business, but what makes each asset in the analysis critical. So we're looking for random distribution. Now, I mentioned that we run these types of distribution models in a histogram. Many people will use a Pareto chart because Pareto chart shows the natural groupings. You can see on the screen the stair-step groupings of the most critical all the way to the right of the least critical. Pareto is a great way to find the top 10%, what people will often refer to as your bad actors. But a Pareto chart, like the one you see on your screen, could be the result of good resolution in the randomly distributed scores. It could also be a modal. It could also be bimodal. So Pareto charts, after we've validated that we have the right level of clarity and resolution in the analysis model, Pareto charts are a great way to start grouping assets together to begin developing your asset management plans and making good decisions. But that's not how we test for resolution. All right, now we're moving through this pretty quickly, so I'm hoping we'll have some good questions towards the end here. We're going to talk about, based on an assumption that we have the right categories that are evaluating or quantifying the value that our business brings and the risk associated with nonconformances, assuming that we have the right level of clarity in the number, we have the right level of resolution. Now we need to start making decisions based on the numbers. So learning from the numbers is our next topic. In the evaluation of the results, there's two types of analysis that we run. There's the bad actor analysis, which, again, I showed an example earlier in a Pareto chart, or you could use the histogram and really looking for, on the y-axis, those assets that are falling into the upper end of the scale range. Or we could look at significance analysis. I like significance analysis. In this example, we kind of see that not all assets are created equal. The purpose of a criticality analysis is to scrutinize the data, examine the data to gain knowledge from the data. In the results on your screen, the caster appears in the upper 20% of the scoring range in the bad actor analysis, with the cooling conveyor a close second. If we were stopping the analysis here and not really scrutinizing the number the way we should be, we may be led to believe that the caster is the most significant, most critical asset. We may make decisions based on that only the caster should be incorporated in a preventive maintenance program, and only the caster itself would be a good candidate for spare part stocking strategies. But some assets may be critical, and not critical because they should be incorporated in a PM program, but critical because of how they impact the business when a nonconformance occurs. So if we look in the radar chart, we're going to see that you've got different lines. If you look at a casting wheel, which is kind of a light green color, we can see that it's significant because of its mean time between failures, how often a nonconformance occurs. If we look in the hydraulic power unit, we can see that it's significant because there's no workarounds feasible because when a single point failure occurs, or that there's a high degree or a high spare spare parts lead time to recover from a nonconformance or a failure. So that makes it significant. So the significance analysis gets us past just what is the raw score and really starts to make us think about what each asset in the analysis itself significant or critical. And this is where we have a bit of a departure from the definition of criticality. Criticality is significance. It's not most important versus least important. We really want to transform our thinking around criticality to significance. Every asset serves a specific quantifiable function, and that's why it's an asset. So we really want to understand what is meaningful about that asset and what do I need to do to manage that asset. I want to look at a couple other ways, or a few other ways, that we can start translating the criticality analysis into significance of the business. The first one that we're going to look at here is corporate risk. If I am a corporate reliability engineer or reliability manager, I might be looking across the enterprise, multiple locations, multiple business units, and I might be responsible for, say, just rotating assets. So I'm using my criticality analysis to figure out within those rotating assets, which assets prevent my ability to increase capacity, plant capacity, and in turn generate more income for the business. Or what assets have an increase, a nonconformance, or based on their current performance, increases cycle time intervals or reduces the efficiency of the process, which may lead to a corporate decision to add more assets to the asset base, reducing the overall return on assets valuation of the company. I might be an internal plant engineer or manager, and I'm trying to figure out from my criticality analysis, how do I improve asset utilization? So I'm looking for, within the analysis itself, which nonconformances lead to downtime, or which nonconformances reduce my rate efficiency or increase the volume of scrap and reduce the volume of value-adding time of production. I could also be looking at the results of my criticality analysis and how those different assets impact maintenance schedules and maintenance labor utilization, because that's a value to the business. We would look at, again, spare parts lead time. We look at complexity of corrective actions, because these things increase the cost of labor, increase the mean time to repair, or cost of maintenance. Our next topic is going to be managing by the numbers. And in this topic, we're really going to look at just some basics around risk management. Criticality analysis should give us the information we need to fundamentally make two decisions. Either I'm going to avoid the activity that lends itself to the risk, or I'm going to go for it, but I need to manage the risk. And those are really the two decisions that, if we refer to ISO 31000 as kind of the standard, the consensus standard for risk management, those are the two decisions that we can make. So, in most cases, if we're just doing a bad actor analysis, a reliability professional might take the results of that analysis and really look for the top 10, top 20% that defines the bad actors. And these reliability specialists would typically proceed with the failure modes effects analysis to assess the failure mode level risks, prioritize those risks, and determine either preventive maintenance action or corrective maintenance actions. But again, we must begin to consider the critical characteristics that are common throughout the organization across all assets, whether they fall into that top 20% or not. In doing so, asset management becomes an enterprise-wide process. For example, if customer impact is commonly critical across multiple assets, then your organization may need to consider equipment redundancy plans. For organizations that find that spare parts lead time is particularly critical across the majority of assets, materials management improvement program might need to be initiated, or either that or you need to avoid those circumstances that require spare parts. And within the organizations that struggle to manage the cost of maintenance or the cost of managing risk, this is where, again, we might see a formalized preventive maintenance program implemented. ISO 31000 helps us deal with risk. And if you'd like more information around risk management and risk management procedures and protocols, I definitely encourage you to get a copy of that standard. Within ISO 31000, there's a risk management cycle, and this is what I mean by managing by the numbers. In that cycle, we begin by identifying the hazards. And hazards relative to asset management is any situation, circumstance, or condition that, or manner of operation that prohibits our ability to add value with the assets. Criticality analysis then becomes the assessment of those risks, of the severity of nonconformance or the probability of nonconformance. We analyze then the risk control measures, and criticality analysis is another useful tool to look at evaluating existing controls and see if they are in fact helping us reduce the impact to the organization. Once we've analyzed the risk based on the known standard or hazards, then we begin to make control decisions. And this is, again, where that learning from the number really comes into place. What is the number telling us? Where do I need to focus my attention? And what roles in the organization should be responsible with coming up with the asset management plan? Then we implement those risk controls. Right? We supervise the implementation or execution of those controls, and again, reevaluate the hazards. And this is that cyclical process that continues. Let's talk a little bit about some of the decisions that we can make relative to number 5, implementing the controls. From a management perspective, we're typically talking about procedural controls and hardware controls. And in both of those, there's both passive and active controls. So I'll talk about what these are, and then we'll look at just the examples on the right of the screen there. Procedural controls are, in effect, they're things that are done by human beings. Procedural controls, because they are a proponent to human error, they are not removing as much risk. They're not as tight of a control if you think of it that way. The matrix you see on your screen is really looking at it from mitigating the risk, the majority of the risk in the high, to leaving you open or exposed to risk in the low. So procedures could be things on passive controls, would be an inspection, a quantitative inspection or test that is really meant to detect that a non-value-adding condition exists. An active control would be a precision maintenance activity or a preventive action that actually removes the condition itself, prevents the condition from happening. Hardware controls, as I meant, are more effective oftentimes because they don't have the human error. And those hardware controls could be things from passively just a warning or a sensor or something that identifies that a non-value-adding condition may exist or is going to exist if we don't react, to installed hardware like a relief valve or a safety interlock that completely eliminates the situation altogether. So we've talked about what's in the number. We've talked about how to maintain the integrity of the number. We've learned a little bit about today how to pull from that number and understand what decisions we should make. And we've just reviewed the ISO 31000 model for managing risk by the numbers. And it all begins with an understanding of significance or criticality within the asset. So as you leave here today, as you go about your business, the things that I would like to leave you with before we begin to answer your question is, how does this change your thinking about asset criticality analysis? What needs to change within your current protocols, or if this is the first time you're learning about asset criticality analysis, what are your takeaways to make sure that you've got the right clarity to make informed decisions? What are you going to do differently to improve asset management based on the application of criticality analysis? And then, I just want to make sure everybody's thinking about, before you leave here today, what's the minimum resolution required for a good criticality analysis result? With that, I thank you for participating in today's webcast. If you have any questions, please feel free to email me at coach@eruditiollc.com. You can visit our website at www.eruditiollc.com or the phone number on your screen, and one of our coaches and subject matter experts would be happy to answer your questions.
Great, Darren. Thanks very much for that presentation, and we're going to get to some questions here in just a moment. If you've got questions for Darren, just type the question into the Ask a Question box on the webcast console and click Send, and we'll get to as many of those as we have time for this afternoon. Questions that are for today's presenters will be answered verbally during the Q&A session. Please also take a moment to answer a few questions from our exit survey that will pop up on your screen at the conclusion of the webcast. We'll use those answers to help shape future plant engineering webcasts on a number of different topics. Within the next 7 days, you'll get an archive with the Q&As. They'll be posted on our website at plantengineering.com. We'll also send an email to all the registered attendees with a hyperlink, and you can access this from the plantengineering.com homepage. So let's get into some of the questions at this point. Darren, let's start with probably the most significant topic in maintenance today, and that's the adoption of ISO 55000. What do you see as the real impact in the short term, and as greater adoption, greater understanding of ISO 55000 comes on down the road? What do you see as the real impact for manufacturers and for plant managers?
Bob, that's been the key question. As one of the initial delegates for the U.S. To Project Committee 251, we really wanted to understand what was going to be the U.S. impact and what was the difference between public and private sector realization of benefit from ISO 55000. What we're seeing right now is there's a little over 100 different government regulatory agencies that met about a month ago and actually adopted ISO 55000 as a consensus standard within their different regulatory bodies. So I think, for manufacturers, especially in regulated forums or industries, what we're going to see is that their traditional auditors are going to be using ISO 55000 as kind of a gut check to make sure that we have the right asset management strategies in place to mitigate risk to the business. So that's the first and foremost. Manufacturing can definitely take a little bit of a back seat and kind of watch what happens in the public sector. The public sector seems to be adopting the standard much more quickly to change their business acumen, to aggressively go in and adjust asset management strategies today. So from a manufacturing perspective, I think we're kind of watching and seeing what is going to happen in the public sector and just how much focus it's going to get. The ISO 55000 is not just written for physical assets. It's written for the tangible and non-physical assets like intellectual properties and those types of things, software, data management, and different aspects that are also valuable to the business. So, there's a lot of room to begin, on the front end, to begin interpreting the standard and figuring out how to apply it for your business before it gets the wheels behind it. So, it's a great opportunity for maintenance and reliability leaders to become more aware of what the standard is and how it applies to their business, and begin, kind of constructing, what are the best practices to execute it.
It seems like in a lot of organizations, awareness is really the first step beyond even the process of managing the assets. It's becoming aware that maintenance and reliability is a strategic process. It's not a calendar-driven process, and while that may have some play in it, it certainly seems like having a maintenance strategy and being able to execute on that strategy on a continuing basis is going to deliver tremendous benefit to everybody involved.
I agree.
Let's look at some of the questions we've got coming in from our audience. What are some of the layers of criticality, and how is that used to determine time and resources applied to engineering reliability strategies?
That's the layers of criticality. I hear this as a pretty common term. When we look at criticality analysis, will often implement the analysis model in layers, and that's really just to make it manageable. If you think of 3,000 assets or 10,000 assets across an enterprise, that's a daunting task to go through and analyze the impact on value of the business. So the layers of criticality, the first way I'll answer that is I highly recommend that you begin by looking at the system level assets, the fundamental groupings of components together for a common purpose. That's how we define systems. So I would look at the baking, the mixing, the cooking, the finishing, the packaging. I'd look at the system level analysis first. Run that through your model, run an analysis distribution report looking for the right level of resolution to make sure you have the right categories, the right number of questions, the right numbers of answers. And then from that, start drilling into the next layer within the most significant system or systems and bring it to the machine level. Still not down at the component level yet, but just at the machine level. And from that machine level analysis, then you're making the first decision on what are the appropriate machines based on their significance for failure mode analysis or some other qualitative analysis that really gets down to why things fail, how they fail, and how much risk is the organization exposed to. If we're using the significance analysis result, then it's similar to the example is I'm not so much concerned about the score, but I'm looking for common characteristics, whether that's spares lead time or whether that's quality impact. I'm looking for the common characteristics across the plant or across business unit and trying to figure out what does my asset management plan need to be. An asset management plan is not just a maintenance plan. It's really how do I mitigate that risk. So those are the different layers that I would start with.
Very good. This cuts across two of the areas that plant engineering readers are most concerned about, maintenance and safety. When equipment is identified as necessary for safety, does that mean it should be critical equipment? Or in other words, can something be identified for safety and not be critical equipment?
I answered the second question, and that is yes. Something can be identified, scoring as high, high as the range allows in the safety category, but relatively insignificant in other categories, and therefore be on the overall scale, overall grand scheme of things, not as critical as other assets. Again, we need to transform our thinking term criticality. It really is significance relative to those different business drivers. So I may have an asset that impacts the customer, impacts regulatory compliance. It's high cost to, my current controls are a high cost. There's no workaround. It's an extremely expensive asset to replace. And that would be more significant than just an asset that impacts safety. So you could have an asset that ranks very high on the safety scale, but not very high on any other scale, and would be less significant than an asset that impacts across all categories.
And that's not in any way to suggest that safety assets wind up being disregarded in that area. There's significant assets, but as you're saying, it's a chance to take a look at your entire enterprise in a much different way with criticality.
That's correct, and that's why I really want to make the distinction between the bad actor analysis, which is probably most commonly used in just running that histogram and say what is the score, really getting away from the score and looking at the significance analysis, what makes each asset critical. I might have an asset management plan that is really just 100% designed towards reducing safety risks, and that might be managed by the safety organization within the company. And then I'm looking at other assets that are impacting more of those categories, and that might be where I'm looking at engineered solutions, redundancy plans. That might be where I'm thinking my time is a reliability engineer to engineer other solutions.
Got it. How do you decide? You alluded to this during the webcast. We talked about spares. How do you decide what are the critical spares? Are there other preventive maintenance methods other than vibration, lubrication, and thermography?
Okay, so two-part question there. Deciding what are critical spares. Again, if I begin with the criticality analysis model and I see that spares lead time comes up in that significance analysis result, and there's just a number of different assets that are indicating that spares lead time is an issue, then I'm going to start digging into a more formal like ABC classification, going through and trying to understand each component, delays, spares lead time, cost of carrying cost or cost of transaction. So I'm going through a more formal, using the criticality analysis to point me in that direction. Just because a nonconformance or a failure of the asset impacts the business doesn't necessarily mean that it's a 100% candidate for spare parts stocking. So I'm going to use my ABC classifications to further dive into that. As far as other predictive maintenance methods like vibration, lube oil, and thermography, those are great ways to reduce the demand on spare parts stocking. So that's the way I kind of interpret that question. If we're using motor circuit analysis, if we're using infrared, we said infrared, ultrasound, anything that is going to help us identify defects sooner reduces the demand on spare parts lead times. So I think predictive technologies are a great countermeasure, a great risk control to reduce those spares lead time risks.
One of the things we talk about with readers when I'm out in facilities is making sure that their spares are stocked appropriately to their more immediate needs. You don't want to have 6 motors sitting on the shelf if your motors only go out once every 2 or 3 years. You've just paid for a whole lot of assets that you can't get any return on. So we're talking about, as I'm learning about this, we're talking about asset management as a process as opposed to maintenance, which tends to be an event.
Correct.
Very good. I think this one's real interesting, and I think it speaks to a lot of the issues that we deal with in the plant floor today. What's the ideal makeup and background of the team that helps determine criticality? What are the people you're looking for that you've seen are best suited to this kind of a job?
It's an easy question to answer, but it's a hard implementation because perceptions get in the way. There are not everybody, different roles in the organization are going to look at that term criticality differently. So the first way I'd like to answer that is first, that's just why it's so important to have those different business characteristics, the categories defined up front. And a good practice is if I'm responsible as the engineer for constructing the model, facilitating the analysis itself, I'm going to go out and meet with my different stakeholders. I'm going to meet with operations and human resources and procurement and environmental health and safety. I'm going to meet with my different stakeholders and maybe even the customer and vendors. That list goes on. And I'm going to determine, within those different categories, what are the right questions I need to ask. And that's going to help me build the analysis model. So I'm doing that kind of in a vacuum, but through an interview process. Once I feel good about the analysis model itself, then I'm going to pull in representatives from each one of those stakeholder groups as well, realizing that initially the analysis is going to go very, very slowly with, if I've got an operator, I've got a maintainer, I've got somebody from the storeroom that understands, lead times and stocking requirements. I may have a vendor or customer representative, different people, involved in that analysis model. It's important to get the different perspectives, but you got to set some ground rules. And when you go into that cross-functional group and all the different perspectives, which is important to have, you need to have a good definition of what constitutes a nonconformance. How are we actually going to make decisions within the analysis itself? So it's a good idea to come in with, backlog histories, maintenance histories, failure histories, operational histories. Come in with those histories and say, okay, this is the more common scenario that, the pump fails to start, or the pump fails to produce 1,200 gallons per minute. And that's the evaluation baseline that we're going to make our decisions on how it impacts our business. So cross-functional group based on the different stakeholders that determine value for your business, but setting some very clear expectations as far as what is the analysis going to be based on. Not every potential situation, but the more common situation.
Very good. And this kind of goes to that and to the question we talked earlier about spares. How do you determine which spare parts and the quantities of spare parts to stock for a critical machine?
Can you repeat that one more time for me?
Sure. How do you determine spare parts and the quantities of those parts to stock for a critical machine?
Okay, so again, I'm going to examine spare part stocking strategies for assets that, as a result of the criticality analysis, indicate that spares lead time is an issue. That's kind of the first way I want to answer that, is just because there's a customer impact or a regulatory impact doesn't necessarily mean that the criticality analysis result is pointing to spare parts as a strategy. So let's be very careful with that one. If spares lead time is an issue, spares lead time is just one characteristic of what you heard me mention before as an ABC classification. And ABC is just ways to group different spare parts, where A are the more significant and typically insurance related, and C's are more of the consumables. They come in, they go out, we buy them in higher quantities, and there's less control. So within that ABC classification, spares lead time is one of the triggers for that. Then we look at each one of those spare parts, and if that part is not on the shelf, what is the impact to production, customers, the process, what have you. We also need to look at the other side of the spectrum, and if we do stock it as a risk mitigation control, what is the cost of owning that asset in inventory? So in order to answer the question, one, I got to see it be high up on the scale in the spares lead time category. It has to have a above average score on impact to the process, and it has to exceed my threshold on carrying cost, whatever that may be. And those things obviously are different, from organization to organization. But I've got to have a result from the ABC classification that says this is an A item or maybe even an upper B item before I'm going to put it in stock.
Good. One of the viewers mentioned your resolution example earlier and asked if the 20 questions assessed are done for all 1,000 assets.
That's a very good follow-up question. So I've got an example from a company right now that has 15 locations, and so we're talking pretty close to 100,000 assets. And when they were starting their criticality analysis for the first time, they built the model based on close to that 100,000 assets. But when they went into their first pilot focus area, there was only about 1,200 assets. So they had to, not only did they reweight the categories based on how that focus area defined value, but they also started culling out or deactivating questions and answers in the data set. It works both ways. So, kind of like the iPhone 3 that was almost illegible. You can go to the other extreme. You can have too many pixels in the screen where it looks like a black screen. So you definitely are going to be, increasing the number of questions and answers and decreasing the number of question and answers based on the number of assets in the data set. If you're using a tool to help you facilitate criticality analysis, it's easier to do, because as you turn on or activate questions and answers, then the assets that you've already analyzed are flagged. I need to go now back and answer these questions for those assets as well. If you're doing it in an Excel sheet, that's a little bit harder to do. But the short and sweet answer is, based on the number, the resolution is first based on the number of assets in the study or in the data set, and the number of questions and answers you need is should equal the square root of that data set. So you could have 10 categories and one question each as kind of a starting point, and that's fine.
Yeah. Here's another question on complexity, but this is across a different spectrum. How do you suggest accomplishing a globally standardized criticality analysis when the facilities portfolio includes multiple industry types. In this example was life sciences, industrial, finance, retail, office, including assets registered with multiple asset types.
No, I think it's a very similar question. What we just had is, the category weighting gives us a lot of flexibility. I would answer this question first by saying, across those different sectors within the enterprise, if we can find, common definitions of value, whether that, it's just a generic, the customer perceives the product or service as valuable, and then we can use the actual questions within that category to drill down into each industry or each sector. In my mind, criticality analysis the model itself can be standardized to make sure that as each business unit, as each department is evaluating risk, they're basing it on what's valuable to the business. But the category weighting, being able to turn on questions, turn off questions, is what gives us the flexibility to go into, whether it's life sciences or finance or retail, go into the different businesses and really evaluate what's their own risk versus the overall enterprise risk.
By the same token, if you've got the same business model across multiple facilities, multiple plants, and for our example, this kind of analysis allows you to look site by site and be able to say, here's what we see as the common things that are performing well at site A and maybe 10% less well at site B, and right on down the line. You're able to do some internal rankings within multiple plants along the producing roughly the same kinds of materials.
Absolutely.
The auto industry, for example, are looking to benchmark these kinds of standards and measurements across their entire organization.
Correct. Yeah.
At what point would you look at the types of materials or parts used, and would you perform a failure investigation?
That's a good question. So I was talking about the layers earlier, and I said that initially getting started, you're going to evaluate criticality at the system level, and then within the more significant system or systems, you're going to drill down to the machine level. This is where bad actor analysis, or that basic Pareto or histogram analysis, is really good to help me. Okay, these are the top 20% most significant machines within those significant systems. The next level down, the next layer in the criticality analysis is actually the formal failure modes, effects, and criticality analysis. So now we're drilling into the machines and trying to say, what are the failure mode risks, to get even more clarity around what decisions do I need to make. And in a failure modes, effects, and criticality analysis, because the style of facilitation is part, problem, and cause, this is going to give me a much clearer picture of what parts present the most inherent risk to the business based on those common business drivers or values. So systems, most significant, then we'd evaluate machines, and then within the top 10, top 20% of those machines, those are candidates for failure modes, effects, and criticality analysis to determine what the spare parts issues are.
Very good. Well, Darren, this has been a great hour of information, and we really appreciate the opportunity to hear from you today. And I want to thank Darren for another outstanding presentation.